Newton's laws, the second law and the third law. But before we start discussing Newton's laws, we are going to review Newton's first law, in which it says that an object will remain at rest or will remain in motion unless an unbalanced force acts on it. So if everybody go to page 145 in their textbook, we're going to look at problem number 10, in which it says, 4 forces act on a hot air balloon, shown from the slide in the figure below. Find the magnitude and direction of the resulting force of the balloon. So you have 4 vectors that are going to be given to you in your problem. So the first thing we always need to do is write our given information, in which, if we look at the problem, it says that we have a vector that's going north, and it's 5,120 newtons. Okay, and this is our balloon, our hot air balloon. Okay, then you also have a vector that's going east. Okay, and it is 950 newtons. You have a vector that's going west, and it is 1,520 newtons, and you have a vector that's going south, and it is 4,050 newtons. Now remember, when we do anything dealing with vectors and we have more than one number on an axis, we have to do vector addition. So in this case, 5120 is our positive axis for the y, and so we're going to subtract 4,050 newtons from that. And so this is going to be 1,070 newtons. Okay, so that's going to be my force in the y direction, or on the y axis. Now, if I need to find the force that's going to be on your x axis, you're going to write f of x, and you're going to take, in this case, it's going to be negative 1520 newtons plus 950 newtons. Okay, this number is negative because it is in the negative area on our line. Okay, and so once you put that in your calculator, you should get 570 newtons. Okay, so now you have both of these components. You can find the magnitude and the direction of the resultant for this balloon. Okay, so if we want to know the magnitude, we know that we need to solve for which variable? Solve for magnitude. What's the equation we should use?
So the f of x, wouldn't it be negative?
Yes, this number is negative. Correct. Thank you. I appreciate that. Okay, so someone give me the equation to find the magnitude. What's the equation? I'll give you a hint.
Square root.
Square root, yes.
Of f of x
Squared. Yes.
Plus f of y squared.
Thank you. Very good. All right. So we know f of y and we know f of x. So we have to do what? Plug in our information. Okay. So we know f of x is a negative 570 newtons squared plus our f of y, 1,070 newtons squared. So let's square our information and take the square root. So this is going to be the square root of 1,469,800. Okay, so you put that in your calculator and you should get your final answer for your magnitude, which is F net, your force net, is 1,1200 newtons. Okay,
So that's your magnitude. Now, how would we find our direction? What equation do we use to find direction? Tan theta. Very good.
Alright, so we're going to say tan theta is equal to the y over x. Very good. So if I'm solving for theta, then I have to take the what to find theta? Inverse. Very good. So theta is the tan inverse of y over x. So now all you have to do is plug and chug. So we knew what f of x is. F of x is negative 570, and we know that y is 1007. Alright, so theta is 62 degrees. Alright. So that's going to be our direction. Our answer is going to be 62 degrees above what? 1,1200 newtons. Okay? So that's your review to solve for Newton's first law. Okay? Now, when we start to talk about Newton's second law, it tells us that the acceleration of an object is directly proportional to the net force acting on the object and inversely proportional to the object's mass. Okay? So the equation that we're going to use for Newton's second law is going to be the summation sign of force equals mass times acceleration. So this is your force, this is your mass, and A is your acceleration. Okay? Now, this is going to be net force. Okay? Net force. Alright? Now, sometimes they'll make you go through Newton's first law to solve for Newton's second law, okay? So you'll actually have to take the vectors and find the force net before you can even do Newton's second law. It just depends on what type of question they ask you in your problem, okay? Now, sigma F, okay, that's the vector sum of all external forces, all right, acting on the object, okay? Now, when we start talking about Newton's third law, so this is Newton's second law here. Alright, when we start talking about Newton's third law, then we're going to be talking about action-reaction forces. And all that tells me is that for every action, there's an equal and opposite reaction, okay? So, if we look at our sample problem on page 131 in our textbook, it tells me Roberto and Lauren are studying across from each other at a wide table. Lauren slides a 2.2 kilogram book towards Roberto. If the net force acting on the book is 1.6 newtons to the right, what is the book's acceleration? Okay, so are we going to be talking about Newton's third law or Newton's second law? Newton's second law, because they asked me for the book's what? Acceleration. Now, what information did they give me to solve this problem?
Gave you the
Okay, they gave me the mass. Okay, so mass is what? 2.2 kilograms. Thank you. And what else did they give you? They gave you the net force. Very good. And what did they say the net force was? 1.6 newtons. All right. So now we have to solve this equation for acceleration. So let's rearrange our equation and solve for acceleration. And so we have to say that if they're being multiplied by each other, then we need to do what to get rid of the mass? Divide, okay? So acceleration is going to be force divided by what? Mass, okay? Now we just have to plug and chug. So it's going to be 1.6 newtons divided by 2.2 kilograms. All right, and our final answer is going to be 0.73 meters per second squared. Now, let me ask you this question. If I was driving my car down the highway and I hit another car, would that represent Newton's third law? What would be the reaction?
It moves.
If I hit another car? I'm driving down the highway and I hit another car, so that's my action. What's going to be the reaction of the other car?
Car hits you. Car hits you.
Kind of move backwards. Okay, depending, right? It could move backwards, but that would be depending on how much force I'm accelerating and how much the car is accelerating in the opposite direction. Okay? I could hit another car, right? So that's called action, reaction, what? Forces. Okay? So for every action, there's always a reaction. All right, so let's go in our textbook and practice some.